Listen for a single click in a darkened lab. Not a shout, not a flash, just a tiny tick on a patient detector. That sound does not belong to the electron alone, nor to the instrument alone. It belongs to the handshake between them. In the quantum world, a fact is born in the meeting, an agreement struck, a story chosen, and a trace left behind that the world can keep. Here, truth is not a solo. Truth is a duet. What, then, is a measurement? It isn't a mysterious gaze or a special moment of human attention. A measurement is an interaction that gets amplified into a record. Particle nudges a sensor. The sensor nudges an amplifier. The amplifier flips a bit in memory. And that bit endures, stable enough to be checked, copied, and compared later. System to detector to amplifier to memory. Somewhere along that chain, the world writes something down in a way that resists being unwritten. That is where a possibility becomes a fact. This means facts can be local at first for someone. Imagine two scientists, Anna and Bo, studying the same quantum system from different rooms with different devices. Anna's apparatus asks one kind of question and logs the answer. Bo's device later asks a different kind of question. Until they compare notes, their descriptions need not match. But when they bring their records together, two diaries laid side by side, the histories reconcile into a single, consistent account. Before the meeting, fact for whom can differ. After the meeting, facts become common ground. Reality becomes shared when records meet. This might sound strange until you notice how ordinary it really is. In everyday life, we accept that a photograph, a receipt, or a time-stamped message can settle a disagreement. Not because the paper is sacred, but because it is a record many eyes can read. Quantum mechanics simply insists on the same humility. Properties are not absolute labels waiting inside objects. They are answers that depend on the question asked and the way it was asked. Consider a small, honest device from a century ago. A magnetic splitter that asks a particle, "Are you pointing up or down along this direction?" Send the same particle through a splitter tilted 90 degrees and you've changed the question. Are you pointing left or right? Each device is perfectly clear about the question it asks, and each will give you a crisp answer. But demand both answers at once, and the notion of the property dissolves. You can ask one, or you can ask the other. You cannot hold both without changing the conversation. The outcome belongs to the relation between system and apparatus. Light tells a similar tale. Pass a beam through a polarizer and it becomes committed, lined up with that direction. Turn a second polarizer to block the first and the beam is stopped cold. Now insert a third in between, angled halfway. Suddenly, some light gets through again. Nothing mystical happened. You changed the dialogue step by step, and the final record reflects the path of questions you chose to ask. Properties in this view are not hidden treasures. They are the way the world answers particular invitations. If we were to summarize the quantum state without equations, we might call it a catalog of expected relationships. A careful listing of which questions asked by which instruments will tend to receive which answers. It is not a portrait of what the system is by itself. It is a guidebook to how it will relate when addressed in different ways. An outcome, then, is an established relation. This system said this to that device. Written as a record the world can carry forward. With this lens, some myths fall away gently. No, consciousness is not required to collapse anything. People are exquisite detectors, not magical ones. No, choosing what to keep in your logbook does not reach back to rewrite yesterday. It only changes which patterns you can recover from the data you allow into the story. And no tight correlations between distant systems do not smuggle messages faster than light. They are promises laid down earlier, honored when the notes are compared later. Quantum mechanics surprises us, but it does not cheat. You may ask, if facts can be relative at first, how does objectivity survive? The answer is redundancy. When the same outcome is copied into many places, into measuring devices, into the scatter of light off an object, into the memory of multiple observers, descriptions align. We don't need to retrace all the mechanisms that spread those copies. We need only notice the consequence. A widely published headline begins to feel absolute. Objectivity is what happens when many independent channels carry the same record. There is a kind of grace in this. Quantum theory does not demand a view from nowhere. It invites careful views from somewhere, each tied to a specific interaction, each honest about how the question shaped the answer. That humility is not a weakness. It is a strength. It tells you exactly how to move from private notes to public fact, name who interacted, how they coupled, what was copied, and when it can be checked, and which other questions you've now traded away. The better you keep this bookkeeping, the clearer your science becomes. Let's gather these ideas in your hands, like a small toolkit you can carry anywhere. First, who interacted? Name the partners. The system matters, but so does the device, the setting, the alignment, the whole handshake that made the record possible. Second, how did they couple? What, precisely, was asked? Up or down, left or right, this color or that? Every apparatus defines the kind of truth it can hear. Third, what was copied? Where is the mark that endures? A click count, a streak on a plate, a bit in memory. Without a record, there is no fact to compare later. Fourth, where and when can it be checked? Stability and redundancy turn a fragile result into something the world can keep. Fifth, which other questions are now off the table? Asking one sharp question can make others unaskable for a while. That's not a tragedy, it's the price of clarity. If this feels natural, it's because you already live this way. You insist on receipts for big purchases. You ask for a second opinion before a big decision. You check timestamps when a message matters. In life, as in physics, clarity arrives when good questions lead to good records, and good records meet. So we return to that single click in the dark. Between the particle and the detector, a story was chosen and a line was written. For Anna and Bo, or for you and me, this is how the maybes narrow into a memory we can share. Not because we discovered a property sitting inside a thing like a forgotten coin, but because we invited the world to answer in a particular way and we kept the answer safe enough to compare. Hold the refrain close. In the quantum world, truth is a duet, not a solo. Facts live in the relationships we establish and the records we preserve. When those records meet, reality becomes common ground. If facts are woven between systems like this, then perhaps something even larger is woven the same way. Perhaps space itself is a pattern of who can talk to whom, and time is the order in which those conversations take place. In the next chapter, we'll follow that thread and see how the fabric of where and when can grow out of the simple act of staying in touch.